Okay, so welcome to today's lecture. My name is Fredrik Heinz, and I'm a professor of computer science at Linköping University in Sweden, where I do research on AI and autonomous systems. And I'm also the coordinator of the EU project TrustLLM. And in this talk, in this lecture, I will give an overview of the activities that we're doing in TrustLLM, basically what we are working towards this trustworthy and factual large language models. But to kind of set the scene, I think it's quite interesting to see. I mean, we all know that AI development is very fast, and that there's a lot of focus and interest, especially in this generative AI, the last couple of years, where you using, for example, text prompts to generate images, or using text prompts to generate videos, and of course the large language models. But we also have the European approach to AI, which I think is very good, namely that we have said that, yes, we do want AI in Europe, but we do not want any AI. We want AI that's human-centered and trustworthy. And with the human-centered, we means that it's not the kind of, the AI itself is not the end goal, but rather what we can do with it. So it's the value created by AI that's important. And also that in order to be trustworthy, we want these models to be lawful, ethical, and robust. So I really think we are taking a good approach. And of course, we also now have the AI Act that is coming into effect. So it was approved and started to apply from early August this year. And of course, now there's like a 2-3 year period when this is being gradually introduced. But the AI Act is here. And now, of course, it becomes very interesting talking about this generative AI tools and AI methods and so on. Are they trustworthy? So this was an image that I generated in a completely different purpose. Namely, I just wanted a picture of a car. And then I had Microsoft Copilot that is using DALL-E to generate this image. And if you just look at the image quickly, I mean, you see a self-driving car in the kind of Google-like image. You have a kind of Alp-like Swiss landscape or something like that in the background, and everything looks nice. But then if you actually look a little bit closer, especially to the right side of this picture, things become much less clear. So first of all, is this car driving on the left side of the road, or is it driving against the traffic? That's less clear. And it's also that there's a lot of different lanes, and the lanes are kind of disappearing. So it's very unclear exactly, is this a trustworthy image of a self-driving car? And actually, I think this is something that we see in many different situations, namely that when you look just kind of quickly, everything looks fine. But when you start to look at the details, it's no longer as clear. A different example is this. So this is Sora, also from OpenAI, which again, you can use this kind of text prompt to generate videos. And if you just look carefully, I mean, if you look casually, this looks like a very photorealistic image of a woman walking around in a neon Tokyo or something. But if you start to look at her feet, so if you follow her feet, you can see that she was taking a bit of skips. So was skipping a bit there, skip again and skip again. And there you see that the legs switched places. And again, I mean, things kind of look nice if you don't look at the details. And now we will see that they're zooming in on her face. You can see the reflection of the pavement in her glasses. But when they zoom out soon, you will see that the purse that she was carrying in her hand is now gone. So unless she has very large pockets, something went wrong here, that it's not keeping this consistency over time. So what these two are examples of are this kind of generated AI content, which on the surface looks very, very nice. And it's quite incredible what can be done. But when you look at the details, there is a lot of small things or errors and mistakes and so on. And now, considering the fact that we have these large language models, which are starting to be used for a wide variety of many different types of tasks. Everything from writing assistance to information retrieval to commercial use to personal use, where you're seeing this kind of tools being used in everyday life, but also in more workplace settings. Of course, there is a major challenge in how should we be able to trust the results from these generative AI models when yeah, I mean, basically we don't have any guarantees. So just so people are a bit aware that how do these systems work. Basically, there are three parts to a ChatGPT-like model. It's the GPT model, the generative pre-trained transformer. So this has been around for about 5 years, these kind of models. And what you do is that you take a large amount of generic text, and then you pre-train them, so that's the P, and you train a generative model. In this case, it's basically taking a sequence of tokens as input. You can see tokens basically as words, but yeah. And then you are trying to predict what's the next token in this sequence. And the underlying model is a transformer, so it's a particular neural network type architecture. So these kind of GPT models, as I said, have been around for a long time, and they're very good at capturing the kind of general content of this text, and can then be used to basically as a statistical model over the training data. So this has been around, but it was not until this second step, namely the fine-tuning, was introduced in ChatGPT in November 2022. So basically, the next step here is that you let people judge the output of these models and the interaction between the model and the user. And you basically try to push this model to generate more of the type of inputs that the user wants and less of the input that, well, the users don't want. So you're basically using the feedback from the users to improve the models to generate more appropriate and more interesting and more relevant output. So this is what was released in 2022. Then what has been added is another layer, this retriever augmented generation layer, where instead of changing the model, you are changing the prompt itself. So basically, instead of taking the prompt that you as a user write directly to the language model, now the model is first analyzing this prompt, trying to fill in relevant contexts, facts, and details to the prompt. So you basically expand the prompt before it's being sent to the language model. And so this doesn't change the model itself, it just changes the input. So with this added feature, actually the factfulness and the kind of quality of this, the output of these language models have been significantly improved. But I would still argue that you cannot trust these kind of ChatGPT models because we still don't know exactly what they have been trained on, what is the data they have been using, and so on. And of course, we have this challenge of basically making things up. We talk about hallucinations. I don't think hallucinations necessarily is a bad thing. If you want a more creative writer, of course, that is exactly what you want. The challenge here is, of course, that it doesn't understand the context, so that in some cases it's very good to do this, but in other cases it's extremely inappropriate. And also that it's doing this with very high confidence. So it's kind of very self-assured that whatever it's doing is correct, even though it might not. We also have this whole challenge of reasoning and mathematical calculations and so on. But of course, here we have two recent developments. First is that now these models are starting to basically generate Python code. So if you ask it about a math problem, what it can do is to generate a Python code to answer a math problem, run this Python code, and then give you the answer back. And of course, now with the latest O1 release, where they actually started to add some form of reasoning, basically searching in the space of possible continuations in order to find a more appropriate answer. So this is there. We see a lot of development on this kind of more logical and reasoning front. But my conclusion is still that you cannot trust these models, but they can be very useful if you know and are aware of these limitations. So basically, that is where we start. So what we want to do in TrustLLM is really how can we build more trustworthy and more factual large language models, and we also want to do that in Europe. And actually, I think one of the major aspects here, or the kind of key realizations, is that without understanding the data that these models have been trained on, it will be very difficult to really get this kind of trustworthiness. So I really think we need to train these models from scratch, and that is what we are doing in this project. So we're basically curating the data, collecting the data, making sure that it's trustworthy. We're doing the pre-training, we're doing the fine-tuning, the alignment, and then we're also building this more applications on top of that, and of course also evaluating these models. So what I want to focus here on today is a little bit kind of overview, but also a little bit on our alignment work and a bit on our evaluation work, where we have done made some good progress. And I should say that we're gathering 11 different partners from Northern Europe. So our focus is on Germanic languages. There are two reasons for that. First, we're making a hypothesis that by training a language model on languages from the same language family, we should have more benefits, more kind of cross-language benefits. But also because we are kind of from these countries, but even though that the focus is on Germanic languages, I mean the methods and the tools and so on that we develop will be generic, so they are not limited to just Germanic languages. So I think there should be a lot of universality here. And we're building very much on the experience of those that have been doing this before. So I mean, where, for example, AI Sweden, who has been responsible for developing a Swedish model, GPT-SWE. We have Fraunhofer, Jülich, and others that have been responsible for developing the German model, OpenGPTX. We have TNO in the Netherlands that is now responsible for the Dutch model, and so on and so forth. So we're really building on experience and expertise of those that have been doing this before. So we're not starting from scratch, but we're really building on this expertise so that we can really push the state of the art here. When it comes to trustworthiness, we are basically focusing on three aspects. So the reliability. So of course we want to increase the factfulness, and so the quality of the responses. We were also interested in fairness. So how do we make this less biased and more representative, and so on and so forth. And we also want to focus on this bit more explainability and reasoning so that we can justify the answers being provided. So the overall objectives of the project is to improve the factual correctness of large language models. So actually, I mean, considering the latest development, I actually think this is slightly less of an issue. So for right now, this has been it's a little bit more lower priority, or rather it's probably a natural consequence of other things that we do. We also want to provide a framework for modular and transferable multilingual large language model training. So one issue which I will show later is that we have these low resource languages. So by having more modular and transferable models, hopefully we can deal with some of these issues related to really low resource languages. We also want to do development of sustainable and trustworthy large language models aligned with European values. So this is really the foundation for everything that we do, that we want these models to be aligned with both regulation, but also values and so on that we have in Europe, so that these models can be really used in practice. We are also very much for collaboration and cooperation. So we want to also help establishing a European ecosystem for large language models. So we are very open for collaborations, discussions, and so on. We also believe that assessment is really one of the keys. So both when it comes to kind of evaluating the quality of models, but also how to assess their uses in real demonstrations. So we're working with a number of different companies and organizations to actually test models in realistic applications, but also to gather the kind of requirements. So what are the things that is necessary for these organizations to be able to integrate these models into their products and services? And last, maybe it should even have been first, we're also very much interested in this kind of large-scale data management for large language models. So how do we collect large amounts of high-quality data, but also how do we kind of process this efficiently? And actually, now that we have, so the project started in November last year, and it's a 3-year project. So we have more than 2 years left to go. And my experience so far is actually the main challenge, and the thing that we really want to focus on is this: how do we collect trustworthy and legal data for large language models, and and also that this is sufficient volumes and quantity for this. So I really think this is one of the key challenges that we're currently trying to address. Because if we're looking at these kind of languages, the amount of data available in them varies very, very much. So if we have something like English, of course, there's huge amounts of English data available. The same goes for programming code. There's large volumes of training data. Actually, German is also pretty decent. And Dutch and Swedish, at least you can see on this chart here. But if you have small languages like Icelandic or things like that, then it becomes much harder. And you might also have even smaller languages like Faroese or Frisish or something like that. Then you have extremely low volumes of data from these languages. So how to deal with both the kind of quality, but also the very different amounts of data in different languages is really a key challenge. So one of the things that I have been working on in different projects is privacy preserving synthetic data generation. I think this is an interesting idea. Actually, it's an interesting idea from several different perspectives, but of course, to be able to use potentially sensitive data, training generative models on this potentially sensitive data, and then generating synthetic data so that the synthetic data is sharing the kind of statistical properties with the original data, but where the connection to individual or private information is lost. So you basically want to do this process in such a way that you maintain the kind of information content while you're reducing or removing the connection to sensitive things. And actually, as part of this process, we can also remove statistical correlations with sensitive attributes. So we can remove, for example, sex or religion or something like that, which shouldn't be shouldn't influence the outcome of this analysis. Then you can remove that correlation in this learning process. Another thing that you can do is that as part of the generation process, where you generate these synthetic data sets, then you can also make sure that all the different groups are equally represented, or that they're represented in relation to the size of the group or something like that. So we can also deal with getting more representative data. So basically, this is a way of dealing both with bias and representativeness, and of course also the fact that we might have low resource languages. So this is research we have done in other projects, but that we're interested in testing and applying to text data. So a second area when it comes to data is alignment. So of course we want these models to be aligned with European values. And alignment is basically we're trying to steer these AI systems towards different peoples or groups' interests, preferences, and so on. So what we want is that these models should be aligned with European values. And in order to do this, we need to collect high quality alignment data for example, for fine tuning. And there is actually some research showing that it might actually be sufficient to have 1,000 high quality examples. So this is one of the targets that we have. But we also need diverse data from many different groups. So of course, there are many ways to do the alignment. You can do it more at the foundation level. You can do this instruction fine tuning, and then you can do preference fine tuning. So alignment comes in several stages of the project. But what we are doing is that we have developed a tool to do our own alignment data collection. So basically the idea is to collect at least 1,000 high quality prompts in all the relevant languages that we are working in. And you can see the progress so far is actually we're done with the Icelandic, or maybe it's the Faroese, sorry. Yeah, Icelandic, we still have some way to go. We can also see that Norwegian is pretty good represented so far, or at least the bokmål version of Norwegian. So basically the idea is to use the humans to do this translation of these prompts, and then to make sure that we have high quality alignment data. So we have developed this crowdsourcing platform. We have started to collect these prompts in some of the languages, and we are now interested also to get more people involved to collect even more high quality data. So if you're interested in helping out, please reach out to Annika, who works at the University of Iceland. As I said, the goal is to reformulate at least 1,000 prompts for each of these languages. And then we will use this in the second phase to actually create the alignment data. And the intention is to publish this as open source data set, so we really can contribute to the community. So basically there are three parts to it. It's about prompt reformulation, so basically translating a prompt from English to one of the languages. But it's also possible to create new prompts to cover new interesting topics when it comes to alignment. And we can also do prompt evaluation, so say whether this is a good or bad prompt. So this is work in progress, and hopefully this should be a really important and interesting high quality alignment data set to kind of align with European values in these various Germanic languages. So assuming now that we have done the pre-training, we have done the alignment, now we have to evaluate the language models. And actually this is another large and challenging problem. So of course, there are many different ways to approaching this with evaluation. We can just try things out on our own, some kind of gut feeling. We can ask several, that we can have more like testing these against each other. We could also use language models as judges, but we could also do more systematic and organized benchmark approaches. So what we're focusing here on is, of course, the more benchmarking approach. And here we're working with a evaluation or benchmarking system called Skandeval. So this is work led by Alexandra Institute in Denmark. So Don Nielsen is the lead here. And the goal here is to develop a robust multilingual benchmark framework. And this should focus this or emphasis that it's a benchmark framework, which should then be possible to add new tasks and new data sets and so on. So what we want to do here is to be able to enable evaluation of implicit language understanding and generation capabilities of these models. So both how good are they at kind of understanding what's being written, but also how good are they at generating output. And we're interested in evaluation of both encoders through fine-tuning and decoders through few-shot evaluations. And actually here there are some results that few-shot inference or decoder models correspond to fine-tuning. So actually there's a connection there as well. So this means that we can actually compare encoders and decoders directly. So one of the key features here is also ease of use. So it's actually very easy to install and to run this. We could also have your models on Hugging Face. When it comes to robustness, we need to evaluate that as well. So there are many different sources of noise when we do the evaluation. So we have the choice of the training examples. For example, when we do this few shot example, but there's also the choice of test examples. There is stochastic elements. I mean, it's using the stochastic gradient descent, which means that there is always this kind of stochasticity in the process. So therefore, we are doing this kind of 10-time bootstrapping of both the training and test examples. So therefore, we get more statistically valid results. So therefore, we can even claim that they're asymptotically correct. So we're trying to make it as deterministic as possible. Finally, it's also multilingual. So currently, the main Germanic languages that are supported is Danish, Swedish, Norwegian, but also Icelandic and Faroese. There's German, Dutch, and English. So they're both kind of evaluation data sets, but they're also prompts for evaluating decoder models that are then localized so that they're being translated to these other languages. So what are the tasks that being included? So we have 4 natural language understanding tasks: text classification, linguistic acceptability, extractive question answering, so basically generating particular answers, and named entity recognition. There's also 3 natural language generation tasks, namely summarization, world knowledge, and common sense reasoning. So there is also, of course, a leaderboard. So if you want to see the latest results, you can always go to scandeval.com, and there we have the results. So there's also a rank score that's computed so that you can see roughly how you're doing. So now maybe the interesting part: what are some of the best performing European models? So I should say that these results are a few months old, so things might have changed slightly, but probably not a huge difference. So if we're looking at English, for example, not very surprising, it's the GPT-4 models that are doing the best here. But you can also see that the Llama models are also doing very well. So we can see the Mistral is doing the best when it comes to the more European models, still pretty okay. If we then go to Dutch, again, it's the GPT model that's the best. And here we see that the Llama 370B model is the second best. And again, we have Mistral towards the lower end, but still doing fairly okay. So in German, it's the GPT-4 model again that's doing the best. So you can see the pattern here. There is also Danish. So here you see all the 3 GPT-4 models on top. But you can also see that there is a Danish version here that's been trained, fine-tuned from the Llama 3 model, Dansk GPT. That's actually doing very well here. So you can see that it's actually possible to do this kind of fine-tuning on some kind of existing large models and then get pretty good results. In Sweden, we see the same. So it's to see that it's the GPT models that are doing very well. Norwegian, it's the same, switching places slightly. We can also hear that we have the Norsk GPT that's also showing up as a decent model or a good model. Icelandic. Here, again, it's the GPT models. And there's also 2 papers if you're interested, so that to read more about the details of these evaluations. So what I've been trying to do here is give a bit of an overview of the work that we are doing in TrustLLM. And I mean, as I said, we really wanted to do this from scratch. If we see more in the kind of work package level, or I mean, the structure that we're working is that we're working with data curation. So here we currently also have a lot of discussions around how to deal with copyright, how to deal with GDPR or other personal information, how to deal with kind of well-known public figures in this, and so on and so forth. So there's a lot of work going on going into this data curation. When it comes to model pre-training, we're currently training a kind of what we call a baseline model. So it's a 7B model, or no, maybe I'm making up there. Maybe it was a 3B model. I'm now a bit uncertain. Sorry about that. So we're training a model anyway to have as a baseline to compare against, so that we can see where we do improvements, whether it's we are seeing that we can make significant improvements over what we have done before. When it comes to model alignment, there we're currently still in the phase of collecting data. So I showed you the work that we were doing on this tool for collecting and collecting alignment data in a variety of different languages. Then we're also interested in this model transfer. So one idea is to use this concept of neural encoders, so that you can actually connect these models from different languages to get this more modular design. But this is still on the research stage, and I mean that kind of comes a bit later in the project. But hopefully we will be able to transfer what has been trained in one language to a model in a different language, and thereby help alleviate this situation or the lack of data in some of these low resource languages. We're also working with a number of use cases and applications. So under leadership of TNO, they're currently in discussions with several different organizations about how can we both collect the requirements, but also how can we build models to actually help them in their application use cases. So for example, we're interested in contextual awareness. We're interested in, for example, factual reliability. So if you have a more medical application, or if you have a museum bot or something like that, then of course this becomes very important. Multilinguality is one of the key aspects, and of course want this to be safe and easy to use. So there are a number of different use cases there. We are also working on developing more the software for the pipelines for both the data pre-processing, the pre-training, and the fine-tuning, and of course the multimetric benchmarks. So you saw a kind of a presentation of the scan-deval framework, which we're currently in the process of both using, but also further improving. And we're very much interested in comparing and testing different language models related to this. So this kind of gives an overview of the overall project. So one question and more kind of going towards the future. I think what's interesting is to see where do we think that this kind of model development will go. So will we continue to see this larger and larger general models? Here I'm actually not completely sure. I think probably what we will see is that the kind of most competent models will probably be these very large general purpose models. But I think when we have identified a particular use case or particular domain, I think what we will see is that we will develop more smaller, more effective models for that particular use case. And I think there are a number of reasons for that. First of all, I mean, of course, cost is a factor. So if you have a larger model, it will be more expensive to run it on this large computing hardware. But you also have the energy and kind of sustainability footprint, which means that if you have smaller models, they will both be cheaper and they will be more sustainable and more kind of environmental friendly. So I think there are a number of reasons to make smaller models. We're also seeing the trend, I would argue, that we are seeing smaller models, but with similar kind of quality as the larger models. So my expectation is that we will see this smaller, but still very high quality to models. But of course, they will be more specialized, so they will have a more narrow scope. So you would need many different models, but put them more tailored. And then we see a lot of interest right now in multimodal models. So, I mean, currently, or I mean, initially, it's been text and images, and of course, also tried to add sound. I think this will probably continue and that we will add more modalities. We also have different types of, say, sensor data or genomics data or other types of data that you can incorporate into the models to actually get better and more interesting results from this. Because I think that the natural next step here is that we're moving away from this kind of language models. I mean, now they're called large language models, but I would expect them to be more general into more kind of large AI models, and that we will see different use cases, not only this text or image or video, but say to generate chemical molecules or generating new materials or generating more structured data for different types of domains and applications. I also think it's very interesting, how do we actually ground these models into either more some kind of physical reality? So we have the I mean, more, or maybe I should say physical world. So if you want to control robots or physical equipment, your understanding of the world needs to be aligned with, or tuned to what these real physical systems need, but also so that the suggestions or say proposed actions, proposed understanding of the world actually make sense in the physical world. I also think we will see, or I think one interesting direction is more scientifically grounded models. So, I mean, we mentioned this about factualness. So I think now they're trying to kind of be generally correct, but I think it would be interesting to have AI models that can actually generate scientifically valid arguments, scientifically valid information, and maybe even from kind of first principles explain or describe how to reach that conclusion. So I think this kind of AI for science and building these models for more scientific application is a very interesting and I think very important field going forward. So we haven't talked so much about the kind of underlying technology, but I mean, today it's basically this transformers-based architectures, the decoder-based GPT models. We are starting to see some of these kind of state-space models. It's unclear if they, of course, they're good when it comes to the kind of context window that they scale linearly instead of quadratic, and so on. But what I really think is missing, or what I think would be the major new next step, is really how can we combine this neural network-based architectures with more symbolic representations? Because, I mean, in some sense, you could argue that text, or at least the thing that the text is talking about, is very much structured, symbolic knowledge about the world or how the world works. I mean, talk about scientific knowledge. This is then encoded in this kind of symbolic representations. So how can we, in a much more fast and efficient way, integrate and combine that knowledge together with this extremely successful and very, very useful, more neural network-based approaches that can adapt and kind of find all the intricacies and details in this data. So that we can combine the best of both worlds. And I think that will also be necessary. We really want to have some guarantees regarding the correctness and the trustworthiness of these solutions. I also think when it comes to testing and evaluation, we have only kind of seen the beginning. So my general, view is that when you see really high results on some benchmark, then I always get a bit skeptical because there's probably been kind of adapted and more, aligned with the benchmark. It probably won't say that much. And how would you connect the actual capabilities of the system to different benchmarks? So for example, I have a particular application here. What are the benchmarks that I should focus on? What are the benchmarks that really tell me something about the quality of these particular models for my application? So I think there's a lot more work in doing in improving and making this testing and evaluation much more rigorous. Because in the end, we want this kind of trustworthy, human-centered AI, and therefore we need to make sure that we as human can trust them, but also that they are being aligned with how we humans want to see this system. So I think these are definitely some of the trends going forward. And of course, we believe that TrustLLM will be one of the contributors to this. Of course, there is a very dynamic and rapidly evolving field where there is so much happening all the time, and it's a lot of impressive and important results being created all the time. But we're trying to keep up and to pick up the good ideas and try to find ways to integrate and combine them into the work, so that in the end we are actually able to develop this trustworthy and hopefully also factual large language models. And of course, we want to do it in Europe to show that we can do it and to provide European alternatives to this great, American and Asian and so on models that already exist. But I think it would be beneficial for democracy and for the kind of European ecosystem to actually have European alternatives to choose from. And then probably it will be difficult for us to compete on, we don't have the resources, neither the money nor the computational resources to really compete with the largest models, but at least we can show that it's possible to do this and to, as I said, provide an alternative. So we're very much looking forward to continuing this project, and maybe I can come back with more towards the end when we have some more results to present from the project. And if anyone is interested in collaborating and discussing and sharing, we are more than open to do that. So please reach out. And if there are any questions, I'm happy to take them. Thank you very much.